Hello, everyone. Welcome to the Unit 5 test review. It's a long test, a long review. I don't know yet. We'll have to see how the timing goes, but I might just break this into two parts. You'll already know that by looking at the title. Um, but we'll see. We'll see how this goes, how much time it takes. We're going to start here, of course, with number one. Number one says, determine if each of the following is a valid statistical question. So to be a valid statistical question, what we're looking for is the question has to be a question where if you ask it to multiple people, each person might have their own response. Like, what's your favorite color? Some people say red, some people say blue, some people say yellow. So it'll change. But if I ask, well, who's the president? Right? Everybody's going to say the same thing, right? Um, so yeah, statistical questions should be something that has a variety of answers and not just like a factual answer. So question one says, how many home runs were hit last? Um, How many home runs were hit last in major leagues last year? What is, I feel like it's worded really weird. How many home runs were hit? I think it meant like in the major leagues last year. Wording of that is really weird. I didn't write that. It's not my fault. But how many home runs were hit in the major leagues last year? And question two, how many home runs did Mike Trout hit last year? Both of these are factual questions. I don't know what the answer is, but whatever it is, it's the same number. So it's not like someone's going to say there were 200 home runs hit last year, and then someone's going to say like, no, there are 500. No, that number exists, right? Whatever it is. So neither of these are something that would be a different answer from person to person. They're both factual questions. So neither of these are valid statistical questions, right? Um, so again, a valid one to give you an example would be like, who's your favorite baseball player? That would be more of a statistical question because when you ask that to different people, they'll give you a different player. Number two, the Department of Tourism in the state of Colorado was interested in the proportion of skiers that prefer snowboarding to traditional skiing. A group of 50 skiers was selected at the largest ski resort in the state and asked if they preferred snowboarding to traditional skiing. Identify the population and sample for this survey. So population and sample. Now population is where the sample is being taken from, right? Um, what's the total amount of people that could have been in that sample? So when they say, 50 skiers were selected at the largest ski resort in the state, well, the population is going to be all skiers at that resort, right? Because they're not doing a random sample of 50 skiers from the state. They're not doing 50 skiers from around the world. They're doing 50 skiers from that ski resort. So the population was all the skiers at that ski resort because they all had a possibility of being chosen. The sample is just the 50 that were chosen. All right, so number three, determine if these studies are experiment or observational studies. So number one says a principal believes that an after-school tutoring program can increase performance on the SATs. The principal selected at a random sample of 50 students that participate in the tutoring program and a random sample of 50 students that do not participate. When the principal compared the average SAT scores of the two groups, the group that went to the tutoring program had on average significantly higher SAT scores. This right here, study one, is observational. It might kind of sound tricky because it sounds like, hey, they're making groups. They have groups, but they're not making any assignments in the groups. It's and the groups were chosen after things that were all people were already doing. People are already in this tutoring program, or they were. These have already happened. An experiment would create those groups, assign people to those groups, and then measure the scores. That's not what happened. Those people are already in the tutoring program, or they're not. We've just taken 50 from each group and then compared those results. Observational study because they did not create these two groups, assign randomly in these two groups, nothing like that. Study two, a physical therapist believes that yoga can help cure a patient from depression more effectively than taking medication. To help determine if this is true, the therapist randomly selects 50 patients and assigns 25 to a yoga class and 25 to an antidepressant. 3 months later, the therapist determined that the group that was assigned to yoga had, on average, less depression than the group that took medication. This one is definitely an experiment. And we can tell that because they are creating these groups and they are assigning to these groups, right? So that's the experiment, right? Again, an experiment will create the groups, assign treatments. Observational studies don't necessarily do that. Number 4, which of the following samples suffers from convenience sampling? I'll go ahead and say, well, let me go through all of them. Sampling all residents in a town and asking them which candidate to support. A, by the way, is a census. So it's not A. Let's zoom in on this a little bit. A census, remember, is when you ask everybody. B says sampling 70 people in a large county by randomly picking names from a list of all residents and asking them how many times a week they eat out. That one is a simple random sample because they have everybody on a list in a hat, basically. They pick 70 at random. That's a simple random sample. C, sampling 100 shoppers at the local mall and asking them how much money they spend on average for a friend's birthday gift. That's your convenient sampling because they're asking 100 shoppers at a local mall, just kind of going out, asking 100 people, boom. There's really no arrangement in setting it up. They just go out, ask the 100 people. It's convenient. It's simple. And the last one, sampling 25 people from a city who fill out a survey online. That one's going to be a voluntary response. So I just want to clarify, what these other ones were, just to help you out with that. But convenience sampling was C. All right, a school district is considering going from traditional school schedule to a year-round school schedule. The district wants to estimate the proportion of parents that are in favor of year-round schooling. Each of the 10,000 students in the district is given a survey that parents are instructed to fill out and have their children return it to school. Of the 251 surveys returned, 63% of parents are in favor of changing to year-round schooling. Which of the following is true about the sample proportion obtained from this sample? So the sample is biased and overestimates the population because of voluntary response. So B and C say the same thing, but B is for convenience sampling, C is for random sampling. And then D, it's not biased. The sample proportion should be approximately the same as the actual proportion. All right. So I'll go ahead and say C doesn't make sense because if it was random sampling, it wouldn't be an over or an underestimate, right? C, if it was random sampling, would say what D is, which is not biased. So those two kind of like clash with each other, C and D. This is biased. And as you can see, 10,000 students, 10,000 surveys were there, but 251 were returned. It's a big margin of surveys that are unreturned, right? These people at home are choosing whether they want to do it or not. That's a voluntary response, right? So it overestimates the proportion because of voluntary response sampling. The reason it overestimates, by the way, is because a lot of people who didn't respond are just going to think it's kind of silly and not respond. But the people who want that to change are more likely to respond. So that's why it's, 63% might be an overestimate of what maybe the real value is. All right. 6. A school wants to estimate the proportion of students that have a part-time job after school. Which of the following samples will likely not be biased because it utilizes random sampling? Place the names of each student in a bag, thoroughly mix the bag, and pick 50 names. That's definitely it. A is our answer. Ask all the members of the varsity football team. That's not good because that's not representative of the school. In the next issue of the school's newspaper include a survey that can be cut out and returned. That would be voluntary response. That's not very helpful. And then D, have a member of the student council ask all their friends. Again, that's convenience sampling. So those other options, not necessarily as good. A, definitely the way to go. If it's random sampling, right? Put them in a bag, mix them up, pick out 50. Number 7, in order to estimate the proportion of students that have a part-time job, the principal at a school selected a random sample of the students enrolled in AP classes. The survey showed that 23% of students had part-time jobs. What potential bias is present in the design of the survey, and is the sample proportion likely to be overestimate or underestimate of the population proportion? So notice, right, or we're wondering what proportion of students have a part-time job. So we get a random sample, but we get of students enrolled in AP classes. And then the results was 23% of them had part-time jobs. So this is likely going to be an underestimate. So sample, and I'll explain why. Sample proportion will underestimate. And the reason why that is because the students in AP classes are probably going to have to stay at home to study more and do more work. They're not really going to have time for a part-time job. Granted, again, some will, as you can see, 23% of them have a part-time job. But because if they have a lot of AP classes and it takes a lot of their time, maybe they don't have a job, right? So fewer AP students will have a job than maybe the typical person, which is why 23% is an underestimate, because we would expect that to be higher if we ask regular people, right? Regular students. So yeah, because of undercoverage. So I'm saying that just because, right, again, you're only serving AP classes. You're not asking people from the whole school. So you're leaving a group of students out. And that is undercoverage. When you're only surveying some instead of all, that's undercoverage. Number 8. The owner of an apartment complex wanted to estimate the mean number of children living in each apartment. One night, the owner knocked on the doors of the apartments and asked the people who were home how many children lived in the home. Of the 60% of the residents that were home, the mean number of children living in the homes was 3.2. What potential bias is present in the design of the survey, and is the sample mean likely to be an overestimate or an underestimate? So it's at night, right? They're going around and asking the people if they have children in their home. Now, 60% of the residents responded, which means, I'm just going to make a little note here, right? That 40% did not respond, right? Because maybe they weren't home. Now, people who aren't home on a night like this are probably people who don't have children, right? People who have children will have to be home to take care of their children. And so if these people aren't home, it's likely that they probably don't have children and they're going out to enjoy their night with friends or whatever. So they're surveying people who are at home, and those people are more likely to have children. So that's going to mean that this average is likely higher than it otherwise would be. Because if we do include the people who aren't there, who don't have children, those would bring the average down, right? Because they don't have children, they don't have children, they don't have children. That's going to lower the average overall. So that 3.2 is likely an overestimate. So sample mean is an overestimate because of non-response. So response is the problem, non-response is the problem because again, 40% of people did not respond. Number 9, in order to estimate the proportion of students that cheat on their homework, the principal of the school selected a random sample of students and asks the students if they cheated on their homework. The survey showed that 31% of students admitted to cheating on their homework. What potential bias is present in the design of this survey and the sample proportion likely to overestimate or underestimate the population proportion. So the principal's going to people and asking them if they cheated. Of course, people are more likely to lie and say they didn't cheat when they did. So you're going to have fewer people confessing, which means that 31% is probably too low of a value. The 31% probably underestimates. So the sample proportion underestimates because of response bias. Response bias is what we see here. It's when you're either led to like kind of like you're lying about your response, or like you're led to say something other than what your opinion is. So in this case, most people are probably lying, saying that they don't cheat on their homework because the principal is asking them to their face. So that's a response bias if they're lying to the surveyor. Number 10. Miss Sillavong has a homeroom with 34 students and needs to select 4 students as representatives to serve on the principal's advisory board. In order to be fair, she decides to select a simple random sample using table of random digits. She obtains a list of students, names in alphabetical order, and numbers of students according to their position on the list with 1 and continuing to 34. She used the following digits to find her random sample. All right, so remember, we're doing this by double digits because we're going from 1 to 34. So we have to break these down by double digits. So if we split these up, go 50, 18, 43, 82, 5, 62, 71, 4, 90, 31, 59, 13, 21, 8, and 52. So every second digit, I drew a line, right? Just space them out. And I'm looking for numbers from 0, 1 to 34. 50 is not between 1 and 34. So that one we're going to skip. But the next number, 18, is. Then we have 43. Again, that's not between 1 and 34. Neither is 82. But the number 5 is. Then I have 62, which again is too big because we're only looking from 1 to 34. 71 is too big. The next number is 4. Of course, then after that, 90 is too big. 31 is good. 31 is between 1 and 34. 59 is too big, and then 13 is good. There we go. And then the rest we didn't need. Make sure these are 5 different numbers. Sometimes they have repeats, and if there's a repeat, we should have skipped it. So there's no repeats in these 5 numbers. They're all between 1 and 34, so we should do a good job here. All right, number 11. When flipping a fair coin, the coin should land heads up 50% of the time. A magic store sells a coin that they claim is not fair. In other words, the proportion of heads when the coin is flipped is actually greater than 50%. To test this claim, Regina flipped the coin in the store, sells for 40 times, and noted that 30 times the coin was heads up. She also ran 200 simulations of size 40, assuming the coin is fair, and the results are shown below. Based on the dot plot, does Regina original sample of 40 flips provide convincing evidence that the proportion of heads is greater than 50? So basically, we're at a magic store. There's a quarter. There's a coin that's supposed to be kind of a rigged coin. That's supposed to land on heads more than it lands on tails. So we try out this coin, and it turns out we landed on heads 30 times out of 40. So 30 heads and 10 tails. Now, the question is that convincing? Is that convincing evidence that that coin is indeed a kind of like a rigged coin? All right. So as you can see from the sampling distribution here, notice how it's kind of centered around 20, right? It makes sense to be centered around 20 because, again, when you're flipping a coin 40 times, you expect half the time to be tails, half the time to be heads. Of course, sometimes you'll land on heads a little less than 20 times, sometimes a little more than 20 times. But in this case, Regina landed on heads 30 times. And as we can see, remember there are 200 simulations, 200 dots in this graph. Only one out of the 200, right, or 0.5%, had a result similar to ours or more extreme. So since 30 heads, I don't want to write this, occurred, 30 heads or more, I should say, 30 heads or more occurred in 1 out of 200 or 0.5% of the simulations, which beats the 5% threshold, because remember, anything less than 5% is where we say convincing evidence. This is less than 5%, of course, because it's 0.5%. So this is convincing evidence that the quarter is rigged. Or more occurred in simulation. We have convincing evidence that the coin is, I don't know, biased towards heads or something like that. Right, will land on heads more often, right? Something like that. All right, number 12. A farmer wishes to determine which of two brands of baby pig pellets, Kent or Mormons, produces better weight gains. Two of his sows each give birth to litters of 10 pigs on the same day. So he decides to give the baby pigs in litter A only Kent pellets, while the pigs in litter B will get only Mormon's pellets. What are the treatments in this study? The treatments are, of course, just the two different brands of pellets, right? Because one litter is going to get the Kent pellets and the other is going to get the Mormon's pellets. So the difference in pellets is the treatments. So the treatments, I was going to say two treatments. And they are Kent pellets and Mormon's pellets. So the type of pellets. There you go. All right, number 13. A company has developed a new drug to help reduce cholesterol levels in people that have high cholesterol. To test this, the company designed an experiment that has 40 patients. 20 randomly selected patients are given the new drug, and the other 20 patients are given a sugar pill that looks and tastes just like the new drug. Besides the new drug, each patient is treated the same. One, such as being educated on how diet can affect cholesterol levels. At the end of the experiment, the average change in cholesterol level is computed to see if the new drug does help reduce cholesterol. Identify the control group and why it is necessary to have a control group. All this just about the control group. So the control group is the group that received the placebo. It creates a baseline for real drug to compare to. That's it. Yeah, if I ever ask what's the point of a control group, just say it's a control group's meant to be a baseline, right? That's what it's for. Control group is meant to perform as a baseline. All right, number 14, an experiment was conducted to see if learning using an online website is as effective as learning from a teacher lecturing. 50 college students volunteered and were placed into two groups. One group of volunteers was given a lesson online, and the other group was taught by a teacher. After the lesson, a test was given to see which group on average scores higher. The scores for the online group were on average higher than the group taught by the teacher. And the difference was statistically significant. What does it mean that the difference is to be statistically significant? Before I read the answer choices, it basically means if it's statistically significant that there's convincing evidence that that one group is better than the other. So the scores on the online group were higher, so we have convincing evidence that the online education was more effective, basically. So if you look at answer C, the observed difference in the average scores in students in two groups is so large that it's unlikely to occur only as a result of random assignments to groups. So the online website does seem to affect the scores on the test. Yes. Statistically significant. So again, what we're kind of saying here is that the scores between the two were different enough. There's a big enough difference between the online score and the teacher taught score to say that the online score is definitely better. That's what we're saying in essentially choice C. Yeah, if the difference was small, it's not significant. It's not statistically significant. So if you see like the differences were small, that's not statistically significant. Trying to look at the other ones. It says it again in B. So again, that already red flags in those responses. If you see that, don't choose it unless it says not statistically significant. If it says not statistically significant, then you would look for the word small. And then why is A wrong? So large that is unlikely to occur only as a result of random assignments to groups. So the online website does not seem. Oh, so that one says does not seem. If it is large enough to make a difference, then it would be better. That's why A is wrong. It's saying that the difference is so big, but it doesn't matter anyway. Like that's not right. C is correct. And then I'm going to end it on this one. We'll end up with part 2 later on with the free response questions. But for the last multiple choice question, here we go. An experiment was conducted to see if a new mosquito repellent worked better than the current brand. 20 volunteers were randomly assigned to one of two groups. The first group used the new repellent, and the second group used the old repellent. Each participant placed their arms in a bin containing mosquitoes, and the number of bites on their arms were counted after 10 minutes. That seems awful. The group that used the old repellent had, on average, 4 more bites on their arms than the group that used the new repellent. Using the data from the experiment, 200 trials of a simulation were performed, and the dot plot below shows the average differences in each trial. Based on the dot plot, are the results statistically significant? I had a little bit of an error. I forgot to put the dot plot here, so we can't actually answer this question, but I will show you the dot plot just for study purposes, and we will answer this question. So let me pull it up 1 second. All right, so here is the dot plot that I forgot to include on this. So again, remember the difference was 4, right? So as you can see in the simulations, there are 200 dots here for 200 simulations, and only one of the simulations had a result of 4, 1 out of 200. So if you're reading your answer choices here, because the difference of 4 only occurred once out of 200 trials, the results are statistically significant. C is our correct answer. Because remember, 1 out of 200, right? 1 out of 200 is less than 5%, right? It's 0.05%. So if it's less than 5%, it is statistically significant. So I'm going to write that, remember. Less than 5% is statistically significant. So try to remember that. Obviously D is wrong because it says it's not statistically significant, so you can clearly rule that one out. Let's see what the other ones are wrong. Because there was a trial that had a sample mean difference of 4. No, it doesn't. It says there was a trial. It doesn't have to be 0%, just has to be less than 5. So it doesn't matter if it's only 1, as long as it's less than 5%, which it was, because 1 out of 200 is 5%. So this one is saying that it did happen, so it's not statistically significant. No, it did happen once out of 200 times, which is statistically significant. So that one's wrong. And because simulations have a center of 0, that has nothing to do with it, right? You have to compare our value of, which was 4, our value of 4 to the rest of the chart. Of course it's centered around 0 because remember, if it's unbiased, then half the time the new mosquito repellent would be better, half the time the old mosquito repellent would be better. So that's why the simulations are that way. But we only care about the result we had in our study, which is 4, which only occurred once out of 200 simulations. So again, yeah, reasons why that one's wrong. All right, C works out. C is a good one. Folks, that's going to do it for the part 1. I'll see you in the free response questions in part 2. All right, bye for now.